6.4 is about logarithmic differentiation, your essential question. I couldn't come up with a really good one, so it's how do you do logarithmic differentiation. So by the time you're done, you want to be able to basically be able to do logarithmic differentiation. So I'm going to start off with an example here. So we're going to have y equals 8 to the x power. And if I wanted you to do dy dx, then what you might say to yourself is, oh, this is a base b function, right? So if I have a base b function, let's say if I wanted to take the derivative with respect to x of b to the x power, let's just recall that that would be b to the x times ln of b. Okay, so this is something you should already know. Especially your last homework problem, I think, had it on there. Okay, well, I can do the same thing here then, right? I can end up with, well, this is really 8 to the x ln of 8. Okay, so keeping that in mind, I'm going to now show you how to do logarithmic differentiation using this and realizing that we actually need to get this as our answer. Okay, so if I start with, and the reason I would use maybe my logarithms here is to get that x out of being variable. So, bring this back down here. What I might want to do is I might want to take the ln of both sides so I can end up without a variable in my exponent. Okay, and then from there I'm going to go ahead and I'm going to differentiate both sides with respect to x. Alright, well, the derivative with respect to x of ln of y is going to be 1 over y. And then I have to chain rule it, right? So I need to take the derivative of what's inside. So then I'll have a dy dx. Okay. On this other side, I'm going to go ahead and take the derivative of this piece with respect to x. So remembering that ln of 8 is just some coefficient. So I'm going to keep ln of 8, take the derivative of x with respect to x, that's just going to give me 1. Now I want to find dy dx, so I'm going to get rid of this 1 over y. I'm basically going to multiply both sides by y. So I get dy dx equals y times the ln of 8. Well, what is y? Y was originally given to us as 8 to the x power. So now I'm just going to take this, what y originally was, and plug it in or substitute it in for y. So we get dy dx equals 8 to the x times the ln of 8. So it matches, okay? And there's a time and place to, just go this route, and there's other times where you're going to need to do logarithmic differentiation, which involves, chain ruling and then potentially having something left that you're going to need to go back and plug it back in. All right, so let's do a couple other types of problems. We'll do 2, so we'll find the derivative. With respect to x. Okay, so I'm going to do 2 of these. So the first one I'll do a. We're going to have f of x equals x cubed plus 4 all raised to the cosine x power. Okay, so this would be a very challenging problem to do if we did not have logarithmic differentiation. Okay, the first thing I'm going to do is I'm going to let f of x equal y. That way I can deal with, dy dx instead of df of x over x dx. That would just be really confusing, okay? So really I have y equals x cubed plus 4 raised to the cosine x power. So now what I want to do is, instead of dealing with this exponent, I'm going to bring it down. And the way I'm going to do that is by taking the derivative of both sides. So I get ln of y equals cosine x ln of x cubed plus 4. Now I want to go through and I want to take the derivative of both sides with respect to x. Okay, so that side and this side. Okay, well the derivative of ln of y is going to be 1 over y times the derivative of the inside is the derivative of y with respect to x. What I see on the right hand side here is a product. So I'm going to use the product rule to take the derivative of the right hand side. So the derivative of the first, well, that'll be negative sine x, times the second, which is ln of x cubed plus 4, plus the first, which is cosine x, times the derivative of the second. And it looks like I'm probably going to run out of room here. So the derivative of the second is going to be 1 over x cubed plus 4 times the derivative of this inside, which is 3x squared. I didn't do so bad. Okay. So I have two terms here that I maybe should simplify. So I'm going to have, let's see, actually, I'm going to get rid of this y right here, and I'll just go ahead and multiply it to the side, just so I can make myself a little bit more room. So I'm going to have dy dx equals, and now I'm going to multiply both sides by y here. Okay, and I have, let's see, negative sine x ln of x cubed plus 4. Plus, how about if I do, I'll multiply the tops here, so 3x squared cosine x over x cubed plus 4. Okay, so I guess the last thing I need to do is really just plug in what y is. So y, originally we had let that be x cubed plus 4 raised to the cosine x. So my final answer will be x cubed plus 4 raised to the cosine x times the rest of this stuff. So I think I'll just go ahead and leave it in brackets. Negative sine x ln of x cubed plus 4 plus 3x squared cosine x all over x cubed plus 4. All right, let's do one more of these. Starting with this problem, I'm going to do two things. First of all, I'm going to rewrite this in terms of y, right? So instead of f of x, I'm going to use y. And then instead of having this radical, it might be better if I rewrote it using rational exponents. Okay, so from here, I'm going to go ahead and take the ln of both sides. And again, the reason why I'm using ln is because we can actually take the derivative of an ln function, so natural log, as opposed to a base 10 function, or base 10 log. Okay, so let's see. So I'm going to take the ln of this quotient. Now, taking the ln of a quotient would be the exact same thing as taking the difference of the ln of the numerator and the denominator, right? So I can then rewrite this as ln of y equals the ln of 3x plus 7 to the 5th power minus the ln of x plus 2 to the 1/3 power. And another wonderful thing that taking the ln allows me to do is to bring down those exponents. So I now get ln of y equals 5 ln of 3x plus 7 minus 1/3 ln of x plus 2. Okay? From there now, I can take the derivative of both sides with respect to x. So taking the derivative again of ln of y is just going to give me 1y, derivative of the inside, dy dx. Now on the right hand side, I'm going to have a bit more work to do. We'll keep this coefficient 5. The derivative of all this is going to be 1 over all that. And then chain rule it, so I'll multiply by 3. Right, derivative of the inside. On the other term here, same thing. 1/3 is a coefficient, I'll keep that. Multiply that by 1 over x plus 2. And if I chain rule that, I just get 1. So you can write the 1 there or not. Okay, from here, I'm going to take this y and bring it over to the other side. So I get dy dx equals y times this quantity, and now I'll start simplifying. So it looks like I get 15 over 3x plus 7 minus, it looks like I get 1 over 3 times x plus 2. Now I'll take that y that I originally had, which is up here, and I'm going to plug it back in. And this would be our final answer.